Hello and welcome to episode 1.3. Today we'll be discussing compound mathematical statements. So first, let's just take a look at this. So this is called a compound logical statement because it has kind of two main statements. And again, these statements are represented as variables. So P and Q are their own statements. So compound logical statement is basically any kind of logical argument like this one, or that has two statements which are represented as variables. So here's another example because you have two individual statements. Here's another example because you have two, and of course you can have more than two, but these examples just have two. So within a compound logical statement, you have three main logical operators, and you may have recognized these from the three previous examples. So you have not right here, and or. So let's break each of these down. So here's the first thing. So not. So not is, the more technical name for not is negation. Not is just how you say it. So this is called a negation, and here's the symbol for it. It's just a tilde. And here's an example of it attached to an individual statement. So you just read this as not P. So let's say that P is equal to Bob is 32. So what this is saying is that Bob is not 32. All you're doing is just kind of flipping, you're adding a not in there. So here's the second example, so and the technical name for this is called a conjunction. And here's the symbol that represents it. It's kind of like an A, except without the horizontal line. And you would say this as P and Q. So let's just say that P is equal to Bob is 32 and Q is Bob likes pizza. You would say this as Bob is 32 and, because the and right here, Bob likes pizza. And then you have a or, and this is called a disjunction right here, and it's represented by a kind of a V shape. So you would say this as P or Q, and again, it's the same thing as previously. Bob is 32 or Bob likes pizza. So there are actually two types of or statements, or kind of ors. There's inclusive and exclusive or. The one that we'll be looking at for the first few lessons are just inclusive. So it's basically like how you would think of or, like I either do this or I do this. That's the kind of or that we're talking about. But I'll explain exclusive or in a later video. So here's a bit of a statement that could be somewhat ambiguous, ambiguity, I don't know the word, ambiguous. So whenever you have a statement like this, that negation only goes with the first statement like you see here. So all this says is that not P and Q. That's all it's saying, which is equivalent to this. And then when you have an example like this is not equal to not P. Oh Lord, my computer had another stroke. Okay, so this is not saying not P and Q. What this is saying is that you take P and Q and then negate that. And that can be a bit confusing because we haven't gone over kind of analyzing the truth values like of these whole statements. But that'll make sense later. Just know that that's not equal to that. Here's another thing you can't do. You can't take like P and Q or R. That has no logical meaning, and kind of it's just a thing that you can't do. So let's take a look at this. So what I'm going to do is just kind of break this down into a common form, which we discussed in the last video, and then replace the logical operators with the symbols. So let's just start by underlining the individual statements. So x is divisible by 2, x is even, or sorry, x squared is even. I got confused for a second. So x squared is even, x is even, x is not divisible by 2. Actually, I'm going to erase that and kind of put it like this. And x squared is not even. Therefore, x squared is not even, and x is not even. So those are all kind of your individual statements. And then let's go ahead and underline the logical operators. So remember that's going to be or, and, or not. So you have or, if then, there's a separate symbol for that, but I'm not going to show you that. So I'll just keep if then, like right, these two, just the way that they are. So you have or, not, and, not, and not. So now let's just go ahead and assign these their own individual variables. So let's say that x is divisible by 2, we'll represent that as p. X squared is even, represent that by q. And x is even, that's going to be, let's just say r. So x is not divisible by 2. Well, if you look up here, we have x is divisible by 2. So remember the not symbol is just a tilde. So all you do is just put not p. And then you have and. I'm not going to leave that the way to, actually I'll go ahead and put those in. So the or is just going to be upside down, or it's just going to be a v. Not, we've already put that there, right, like right here. And it's just an a without the horizontal line. You have not, but you also have your statement, so it's going to be not. And then let's take a look. So x squared is not even. Well, this says x squared is even, so the negation of x squared is even. It's just going to be not q. So not q, that should be red, not yellow. And then you have x squared is not even, which this is getting a bit messy now, but if we have that right here, you do the same thing, because x is even, that turns into x is not even, so all you do is put the not symbol. That turns it into not q. And then you have and, again, x is not even. So that's the same thing as you see up here as r, but it's not even because you're negating it, so it's going to be not r. So at a certain point you can do this in your head, you don't have to write all of these down. But once we write this all in its kind of own form, this turns into p or q, because you have, or actually I'll put the if then. And again, there's a symbol to represent if then, but I'm keeping it as this for now. So if p or let me get my highlighter up. So if p or q, then r. So if p or q, then r. And then you go to a new line, put your period. X is not divisible by p, that's just not, or by 2, that's just not p. So you just put not p. And so you just put your a looking symbol. And then you have not q. So you just put not q. And then you have therefore, and if you remember from the last video, therefore, the symbol that represents that word is just 3 dots in a triangle like that. So therefore, x squared is not even. So that's going to be not q. And, so you have your and right here, so you just put and then you have x is not even. So if you look up here, x is even is just r. So in order to negate r, you just put not r. So here's a quick recap. So a not, the technical name for it is negation, which basically just means kind of, or the kind of intuitive way that I think about it is you're just flipping it. So you're flipping it from is to not, or you're flipping it from not to is. And you can actually have two negations in a row like this, and this is the same thing as P, because think about it. Let's just say that P is equal to yes. You negate yes, that's turning into no, so it crosses out this negation. And then you negate no to turn back to yes, so that's just P is equal to P. We'll look at that more deeply in a future video. You have and, which is called a conjunction, and that's represented by this symbol. And then you have or, which is called a disjunction, which is represented by the V-shaped symbol.